everybody. So I will try to present you the use of machine learning tools or method for the clinician and what we can produce that could be useful for the clinician. First, I will introduce the concept that we are using. First is artificial intelligence and neuroimaging, and how we can combine those two measurements and models to be useful, to extract useful measurements to study and understand mental disorders. And then I will present you, so it's one, sorry. I will present you some application where we use neuroimaging combined with machine learning models to build prognosis tools for schizophrenia and bipolar disorder. And you'll see that the database that I use are very small, not that big. So I choose small data sets. We can do nice science with small data sets. First, I will present you artificial intelligence, then neuroimaging, how it can be useful for psychiatry. So what is artificial intelligence? Basically, it's just to discover relevant patterns that are associated with some semantic information within a set of observations. So here you see images of cats and dogs, and you see that the color of the cat is not associated with the concept of being a cat or dog. You have black cat, black dog, brown cat, brown dog. And also the rotation of the head is not associated with the semantic of being a cat or a dog. So basically what you do when you do AI, you try to get rid of what is not associated with semantic, and you compress all the information within another space that retain only what is associated with semantic. And if you are able to do so, when a new image come out, you project this new image in your data compressor, and this new image will fall in the territory of dog, and you would say it's a dog. So what we call artificial intelligence mainly is to discover patterns within a set of observation or data, and to discover what is relevant and associated with semantic. So I wouldn't say it's artificial intelligence. We really prefer to use the term statistical learning or machine learning, because we are discovering patterns that replicate across the data. So I will talk about machine learning rather than artificial intelligence. So now we'll switch to neuroimaging, how it can be useful for studying psychiatry. So there is a whole brain maturation process from fetal phase to adulthood. And the idea is that neuroimaging could be an imprint or a measurement that could be useful to detect trajectories. So the interesting things with neuroimaging is that it's a combination of the genetic variability and the interaction with the environment. If you are subject to abuse, stress, or having toxics, it will let some kind of, it will let some kind of, some kind of imprint in the brain. And the idea is that we could use artificial intelligence or machine learning to detect the imprint in the brain. But you have to understand that the imprint left in the brain is just 5% of gray matter loss, a small modification of the functional connectivity. It's those very tiny signals that cannot be seen by a radiologist. So here we need automatic tools to process the data and to discover and combine this 5% of loss here, 5% of loss here, in order to build something that could be useful to detect resilience trajectory or trajectory toward mental disorder. So that's the main idea. So basically what we want to do is to use neuroimaging to build some kind of measurement that could be considered as a thermometer, and the thermometer would provide information about the trajectory and the evolution of participants that could be provided to the clinician. But first, you have to understand that a thermometer doesn't replace the person who is using the thermometer. It's just a thermometer. Second, the measurement will not tell you, or the brain-based measurement or prognosis of the trajectory will not tell you what the patient will be. It will tell you, from what I've seen, I could tell you that the participant should go toward this chronic disorder trajectory with something like 80% of chance. It will not tell you the future. So just have in mind this idea that all those tools don't tell you the future, but what should happen according to what they have seen already in the data set. But just to make clear, what can do those tools and what they cannot do. So why it could be useful? It could be useful because if you use all those heterogeneity on the patient, you can use those tools to break down the heterogeneity and find out that there are subgroups of participants that share the same clinical category, but that they had this clinical category for different reasons, for their different etiologies. So for different etiologies, you will have different treatments. So that's the idea, is to break down the heterogeneity within subgroups that are more homogeneous. So as a conclusion from now, the present, what the present tells us is that if you take all the psychiatric disorder, you take them and you do case control study and you want to classify using AI or machine learning tools according to anatomical, functional, or diffusion MRI, you can do this prediction with a prediction rate which is higher than random, clearly. It is not 90% of classification, but it is clearly better than random. This means that the information is present in neuroimaging. But what it also means, it is not 100% of classification. So we still have errors. And lastly, what we have done so far is not really useful because those are always a case control study. And it is not useful from a clinical point of view. What we need for the future is not case control study, but we need what has been mentioned earlier. We need trajectories, and we need longitudinal data sets, and we need to be able to indeed find trajectory. And this longitudinal data set might be an issue, might be a solution to the earlier discussion, because if you have longitudinal data set, you break down the inter-individual heterogeneity because you see what is changing across the time, and you'll be able to find out what is related, what changes are related to some kind of evolution toward some resilience or chronic disorder. I think it's a better way to see phenotypes that are associated with disorder. But there is a large problem. The problem is cost, and the problem is the possibility for clinical structure to do to acquire those data sets. So we have to address this large problem and by setting up structure that will be able to collect those data, those longitudinal data, not always that big, but nice longitudinal data, and asking a clear scientific question. And we need structure, we need research program, but at the scale of the country or at the scale of the continent, at the scale of Europe. And my point here is that with Jean-François, we are involved in this effort to collect the data in order to see how those data could be associated with evolution toward psychiatric issue and tell us what is the part of the brain which is associated with that, and then we we might be able to provide some cue for other biological research. So now we'll provide the application, simple application, not on large data sets, you'll see. It's an application that has been conducted with colleagues in Saint-Anne Hospital. We have participants that are adolescents, and they will move from first psychotic episode, and then they could move to chronic psychosis. And the goal here was to say whether we are able to detect if a participant or an adolescent will move toward chronic psychosis. And this is the subject of a research program, CEA, where we will collect a lot of data. Because if we are able to do that, we will be able to dedicate the resource of the hospital to the ones that are at risk to evolve toward chronic psychosis. That's the idea. And or at least we could be able to say to some people, don't use cannabis or things like that. And here I will focus on a specific example. It's a project we have performed with Anton Eftimovici and Marodier Krebs in Saint-Anne Hospital as well. Also, we had participants that are at risk of transition toward psychosis, and some then were transitor and some not. And the goal was to say, are we able to predict the one that will move toward transition and the one that will remain non-transitor? And we use some kind of machine learning algorithm. We could end up with some kind of brain signature of the transition toward psychosis. And then we say, okay, maybe we can try to explain what happens. And the idea was to say, okay, maybe there are some maturation asynchrony that occur here during the neural pruning of the brain. And indeed, this is what we've done. I won't go into many details of what happens, but basically what we observe and what we think that is going on is that some brain parts have accelerated brain maturation, while some other have delayed brain maturation, and that could be a way to provide biological marker of the evolution toward first episode psychosis, but also to try to understand what's behind this signature. So then I will move to another example. It was whether we can build a predictor of response to lithium for patients with bipolar disorder. So you have patients, you scan them, you provide them lithium, then you see whether they are response to lithium or not. And basically, the goal is to say, okay, can we build a predictor of the response to lithium such that if you know that, you'll be able to give lithium to the possible good responder and to go to another therapeutic strategy for the ones that are not good responder. And this is a work that has been conducted with Jocelyn, Fawzi Boumesber, and Franck Bellivier. And we don't have predictor yet, but what we have actually is that we have map of lithium, because it was lithium imaging, where we see that the lithium concentration is higher than in other parts of the brain, and basically it's close to the hippocampus. And we know that there is a role of lithium associated to neurogenesis, and we think we could find nice biomarker of effect of lithium using neuroimaging. So as a conclusion, what I'm saying is that we could combine neuroimaging and machine learning tools to provide biological-based measurements of the possible evolution of the participant. So it might change the way we see psychiatry, and psychiatry might might be more similar to other medical specialties, where you have blood-based measurement to determine the therapeutic strategy. The second point I really think, which is crucial, is we need longitudinal cohort. We need to see evolution of participants. It's complex to do the recruitment of such cohort. That takes time, money, etc. But I think it's mandatory to find brain-based measurement that could be associated to the evolution of the participant. And finally, I think having that's not a question to the clinician, but the question is whether having brain-based or biological-based measurement, I think that might be useful in the relation for the clinician with the patient. When you say, okay, your kids should have risk to evolve toward this disorder, and the family of the kids say, okay, do you believe it, doctor? It's not a belief. So if clinicians have biological-based measurement, that might be useful to address the relation with the families and the patient. But that's more a question to the clinician, and that's all. Thank you, everybody.